In question 10, it says equilateral triangle XYZ is inscribed in a circle with diameter 6. So here is X, Y, Z. And then it says tangent segments through the points X, Y, and Z meet to form another triangle circumscribing the circle. Determine the sum of the perimeters of this second triangle and X, Y, Z. Now, as it turns out, this new triangle is also equilateral. Now, we know that with this triangle, we have a diameter of 6, which means it has a radius of 3. So let me draw that. Now, the key thing to note is that in all equilateral triangles, the angles are always 60 degrees. And so this perfectly cuts this angle in half. So this is 30 right here, and this is 30 right here. And so by drawing this, what we've created is a 30, 60, 90 right triangle. And so this length of this radius of 3 is actually the hypotenuse of this triangle. So the shorter side is half that, 3 halves. And so this side is 3 halves radical 3. So that means this entire side, since it's equilateral, is going to be 3 radical 3. So that means the perimeter of XYZ is going to equal 3 radical 3 plus 3 radical 3 plus 3 radical 3. So that's going to be 9 radical 3. Now, because we also know that this is 3 radical 3, as it turns out, so is this. Because when you inscribe an equilateral triangle like this inside of another equilateral triangle, this also turns out to be 3 radical 3. Now, if you're not sure about that, what you can do is you can work like this and say, all right, we know that this circle has a radius of 3. And we've got this, It's not drawn to scale, but that's okay. If I connect this like that, this is also 30 degrees. So that means this is 3 radical 3, just as this is 3 radical 3. So the perimeter of the second triangle is 6 radical 3 plus 6 radical 3 plus 6 radical 3. So that's 18 radical 3. So we want the total of these two, and thankfully they're both in terms of the same radical. So when we add them, we get 27 radical 3 as the combined perimeters. And there's our answer, and we're done.